Okay, here we go. We are continuing talking about modeling linear functions. And so we have 3 examples on your worksheet. And so the first, we went through the electricity use for the annual household, and I talked about how you had to, typically you have to make a scatter plot and see if your data fits a pattern that looks linear, and if it does, then you write the equation of the line. But if they say, model this with a linear function, then you know you're supposed to write the equation of a line and not a parabola or an exponential function or something like that. So let's see here. The example that we have is about airfare rates. And so it says a Lockheed L 1011 passenger jet has 500 seats. The airline records show that at $350 a ticket, they sell 380 seats. At $410 a ticket, they sell 330 seats. And at $470 a ticket, they sell only 280 seats. Use the given data, predict how many seats would sell if the airline charged $300 a ticket. So when you read this problem, you kind of hear some points. You kind of hear data points being given out. And so here is what I hear. I hear that if they charge $350 a ticket, then they sell 380 seats. And if they charge $410, then they sell 330 seats. And if they charge $470, then they sell 280 seats. I see some points. I hear some points. This would be my x coordinate and this would be my y coordinate. So it's really, this next step is really important. Write down what x represents. So x represents the price of an airline ticket. All right, and y represents the number of seats sold. The number of seats sold. All right. Now, what you would do, it says using the given data, predict the ticket price for 2020. And do you think the ticket prices will reach $200 each by 2030? Why or why not? Use data to back up your decision. So that's what we have to do in this example. So you might, and I can even do like a little casual sketch to see what these, I have 3 data points. Let's just see what they might look like. If this is, I'm going to go by 100. Let's say this is 100 or 50, 100, 150, 200, 250, 300, 400, 450, 350, 400. And this is my x-axis, so this is the price, right? So we went up to 470, so let me just extend this. This is 450, 500. Okay, so a little casual look at this. And this is the seats sold. This is the seats. And so this is, if we go by the same scale, I could go, this would be 100, this would be 200, this would be 300, let's see, this would be about 400, so that's 350, 250, 150, 50. So this is 100, 200, 300. So if I just did a little sketch, this is rough, but we can get an idea if this looks linear or not. At $350, so this is the money. At $350, I'm right there. I'd be up at 380. So this would be up at 300, 350, 380 would be about right there. Okay. At 410, I'd be at 330. So I'd be at 410, it's close to the 400. I'd be up here at 3. That's 250. This is 300. 330 would be close to 350, maybe about right there. So let's look at this last point and see if it looks like it's going to fall in the line. At 470, 450, 470 would be about there. We're up here at 280. That's 250. This is 280, about right there. And if I look at those, it sure does look like they are falling in a linear pattern. So that would be enough for me to say, let's model this with the linear model, or write the equation of a line with these points. To write the equation of a line, you need two things. You need the slope and any point. We have 3 points, so let's find the slope. Let's pick 2 points. I just picked the first 2, and let's calculate the slope. These are my y values, these are my x values. So m is y2, I'll say 330 minus 380. This is money, right? 330 minus 380 over 410. Oh no, that's not money, this is seats. Sorry. Over 410 minus 350. And that gives us, what does that give us? 330 minus 380 is a negative 50. And then 410 minus 350 gives us 60. So this is negative 5 over 6 is our slope. To write the equation, y minus y1 is m times x minus x1. Let's choose one of these points to be our x1, y1. Let's choose this one. You wouldn't have to choose that one, but you would need to choose one of the points that you use to get the slope. That would be important. So if, for instance, I chose these last two, if I got the slope using these two, then I would have to use one of these for this part of the equation. I'll choose the top one. Y minus 380 is equal to negative 5 over 6 times x minus 350. Now we'll solve for y. Y is equal to negative 5 over 6x plus, let's see, 350 times 5 is 1750 divided by 6 plus 380 over 1. Okay, so if I'm going to use the fractions, I'll say times 6 times 6. 380 times 6 gives me 2280. If I add those two numbers together, I get 4030 divided by 6. I wonder if that goes in evenly. I don't even know. It doesn't. Okay. Y is negative 5 over 6x plus this. This is in fractions. Now, if you didn't have to stay in fractions and you wanted to use decimal, then this would equal to, y would equal to, what is this number, 430, there's a plus right here. 430 over 6 is 671.7. Negative 5 divided by 6 is negative 0.83x. Okay, so if you wrote it in decimal, that's what you could get. Here is the deal. We have to use this to predict, and I'm going to call this f of x at this point, to predict the ticket price. Let's see, what does it say? Do you think the prices will reach $200 by, no, using the given data, predict the ticket price for 2020. How would we do that? Oh, I'm getting my problems mixed up. Let me go back. Using the given data, predict how many seats would sell if the airline charged $300 a ticket. I'm so sorry. I was reading the wrong problem when I was talking about the prediction. I think that probably confused a lot of y'all. It confused me as well, so I'm sorry. Now I'm back on the airfare rates problem. It says, using the given data, predict how many seats would sell if the airline charged $300 per ticket. We can do that. How much will they sell? Y is how many seats are sold. So this is Y. How many seats will sell if they charge $300 per ticket? So to answer that question, we're going to plug in $300 for X and say, what is F of 300? That would be negative 5 over 6 times 300 plus 4030 over 6. Or you could use the decimal form. It's okay. So I'm going to say negative 5 times 300 plus 4030 divided by 6. That gives me 421.6. So I'm going to be conservative in my estimate and say they would sell 421 seats would be sold if you round down. Okay, then they said, do you think ticket prices will reach $200 by 2030? Do you think it'll lower to $200 by 2030? Why or why not use the data to back up your decision? So according to this model, do we think that by 2030 it's going to get down to $200? Well, let's see. How many seats would they sell if they sold it for $200? Let's just see. What is F? I'm going to need some more room. So what is F of 200? Let's just see how many they'd sell. That would be -5/6 times 200 plus 4030/6. So it's -5 divided by 6 is this times 200 plus 4030 divided by 6. They would sell, how many seats would they sell? They'd say sell 505. Based on this statement right here, that the very first sentence it says, this passenger jet has 500 seats, I would say no. They would not sell tickets for $200 because if they sold out, they would sell 505. But you could also reason that the loss that they would take on those 5 tickets, what would that be, $1,000, might justify the fact that they would sort of lower their price so they could sell out the plane. So I mean, there's some reasoning you could use, but if you were just not reasoning, you're just like, look, can't even fit that many people. No, they wouldn't lower the price that much. But let me just say this. We are in a crazy time right now where there's coronavirus. And I saw round trip tickets from Orlando to Atlanta for $21 a week ago. So really, that brings us to this point. Models are good for a set time, but only for a set time. We could say, what do we predict ticket prices will be during the season of trying to recover from coronavirus? I'll bet you we'll see a pattern there. We could model that. And then after 4 or 5 months, when the economy's different, we'll see another pattern emerge. So models are good for a time, but not really forever. So that's just something to take note of. Okay, let's do one more example. Let's do the Disney World example because I started actually talking about it accidentally when I was doing this one. Let's do that one, okay. And also, let's just say this, coronavirus. Who could have predicted what we're about to look at would have made sense a few months ago, but now this problem, you're like, who knows what's going to happen? So anyway, let's just pretend like it was a few months ago, okay. Tickets to Disney World were priced at $3.50 each when the gates first opened. Maybe we're going to go back that way. I don't know. Throughout the years, ticket prices have increased. The Disney records show that in 2006, a ticket sold for $67. In 2010, the ticket sold for $82, and in 2014, for $99. Use the given data to predict the ticket price for 2020. That is really super funny because it's 2020, and I wonder what the ticket prices are going to be when they reopen their gates. So anyway, do you think the ticket prices will reach $200 by 2030? Okay, this is where I was talking about the other problem. Why or why not use the data to break up your decision? Okay, so here we go. Let us do this one. Disney ticket prices. Okay. And so now all of this new Corona world, none of this really fits, but we can still learn how to model data. In fact, one of my students who I have her for either college algebra or pre-calculus, I can't remember, we looked at exponential functions, which we're going to look at later in this course. And so when the coronavirus first broke out, I got an email from her saying, hey, thanks to you, I knew what the exponential model of this virus looked like because that's what all the models of how many people were getting sick was showing. So it's unfortunate, but you could have modeled it off of an exponential curve where it was going really high. Okay, here we go. Airfare rates. that one. Walt Disney World. Tickets to Walt Disney World were priced at $3.50 each when the gates first opened. When I first read this, did you hear the points coming at you? X, Y values? That's what I hear. So throughout the years, the prices have increased. The Disney records show that in 2006, so we'll write 2006, the ticket sold for $67. And in 2010, a ticket sold for $82. And in 2014, tickets sold for $99. Okay, so what's going on here? This is my X and this is my Y. This is something I want to point out to you. When you're given data like this, a word problem like this, and they give you a year or a point in time, time is your independent value. Time drives what happens other places. So X is our independent value. So if it's a year, if it's seconds, if it's minutes, that's going to be your X coordinate, and Y is going to be the other one. All right, so X is the year, okay, and Y is the price. Okay, so let us talk about normalizing our data. When we first started taking this data, 2006 was our first year, so we're going to normalize this. So when X is 0, that's going to be our starting year. So 0 stands for 2006, and so X means the number of years after 2006. Year after 2006. So we are going to normalize this data. So let me just say 2006 is year 0. So this is going to be year 4 because this is 4 years after. 2014 is going to be year 8. So these are the points really 0, 67, 8, 99, 4, 82. So we could draw another graph and see if they lined up linear. I think they will. We're going to go ahead and model it with the linear model. So let's just say they said write a linear model, which means write the equation of a line. So let's choose 2 points. Here I'm going to clean this up. This is 0, 67. This is 4, 82. I'm going to choose these 2 points because this one has a 0 in it, and that makes the math a little easier. M is change in Y, rise, over change in X, run. So it's going to be 82 minus 67 over 4 minus 0. 82 minus 67 is 15. 4 minus 0 is 4. So the slope is 15 over 4. And then I need to pick a point. I'll choose this one because it's got a 0 in it to be my x1, y1. So y minus y1 is equal to m times x minus x1. So we'll solve this equation. Y minus 67 is equal to 15 over 4 times x. Y is equal to 15 over 4 times x plus 67. What does y represent? Y is the price. And if I want to call this f of x, that's fine. The price is driven by what year we're in. Now what did they, this is our model. This is our linear model. Now what did they say? They said use the given data, predict the ticket price for 2020. So what year, how many years have passed since we started taking data in 2006 if we're in 2020? And we are in 2020. All right, how many years have passed? 14 years have passed. So this is what our x value is going to be. What is f of 14? All right, so let's just say 15 divided by 4 times 14 plus 67 is 119.50. $119.50. That's how much, if this pattern continues, the price will be in 2020. That's not far off, and before we had coronavirus. Now I just don't know what's going to happen. But I don't think that that's all that far off for how much tickets prices could be asked if everything had continued like it were, because they were just really getting high. Let's see, do you think the ticket price will reach $200 by 2030? Why or why not? Use data to make your decision. So let's just see. 2030, how many years after 2006 would that be? That would be 24 years. So what is f of 24? That'd be 15 over 4. So this is what we say in 2030 the ticket price would be. This is 2020. Would be times 14 plus 67. Let's just see what that would give us. 15 divided by 4. Wait. 24 is what I meant to put in this time. 24. Okay. 15 over 4 times 24 plus 67. The price would be $157 in 2030. You could argue that, yeah, you think that everything's going to be so inflated that is going to be price that people would be willing to pay, or you could say, look, I don't care how cute that mouse is, there's no way I'm gonna spend that much money to go be in a park that close to people where we can catch diseases so easy. So, you could argue either way. I would probably argue that no, they won't reach this amount, but you never know, do you? Okay, anyway, that is linear models.